Hello my friends, and welcome. In this video I would like to show you my PEMF circuit. Right now it's in the prototype stage, and it's kind of looking messy and everything, but I'll explain everything. I'll explain how it works and show you how it works. So based on this circuit, this is a simplified version of the circuit that you just saw below. I'm gonna go over components and show you that all of the components that in this circuit they're installed in a circuit that I made here below, and I'll explain how they work. So first one is the transformer, which is this component here, and the transformer is here. The second is a diode bridge, which is right here. We have a diode bridge right here. Then I have three capacitors. Each one is 10,000 microfarad, 100 volt. Here I have two large capacitors. They're each 1600 microfarad, and they're 450 volts each. So I can charge them to 450 volts. Then I have reverse voltage blocking diode. There is one here and there is a second one here. So in my circuit they're right here. This is the reverse blocking voltage diode. I actually have three of them. So there's two and there is one more here. So I double this. I put another one here because one diode opens up quicker than another one, and so it catches the first spike, and the second one helps it with the current to discharge everything. Alright, the MOSFET. This is the main component in this circuit, and it's right here. Let me show you. It's installed right here underneath this. There's three wires going to it: gate, source, and drain. And it's installed on a heatsink, and it's being actively cooled by the fan. I don't think it's required, but I'm testing it out right now. I'm probably not gonna use the fan because it doesn't heat up much. Alright, let's move on. Optocoupler here is the optocoupler right here. Pulse generator, which is this one here. Here is the pulse generator, and then I have 12 volt circuit right here, and 12 volt circuit. Currently I'm using the power supply here. This is a 12 volt power supply 1, and then I'm drawing the power 12 volt from here, and I'm drawing a 5 volt from here. So I have three, and this is my four power supplies here, but later on I'm gonna combine them all and make it so that this is the main power supply to recharge these capacitors, and then I'll have just one 12 volt power supply that will feed everything here. So also, instead of switch, as you can see here, I have a circuit, and what this circuit does, it monitors the current flow into this transformer. Anytime 300 watts being consumed, this circuit there is a current transformer. The transformer, this blue component here, that's like a sensor, and it senses the current, and it shuts off the signal with this relay right here, basically allowing these capacitors to charge and making it burst, switching into burst mode. So also in this circuit I have, as you see here, I have a larger transformer. So this transformer allows me to have 5 different voltages here. It has a 2 primary and a 3 secondary winding. The last winding, which is this thick wire, I winded myself, and this last winding is a 60 volt winding, and underneath there is 2 windings. One is 120 volt and another one 120 volt, and this is a 300 watt transformer, toroidal transformer. Also, I have a digital watt meter, and it's helpful, you'll see. Also, in this circuit I have 4 signals that I can work with. There's 2 signals that are built in, which are two main frequencies. So first frequency 432 hertz, and it's being recorded on this chip right here. And second frequency right here is 528 hertz. These are the healing frequencies that could be later on will be used to drive this coil right here. So there is basically two frequencies here, and I can choose in between them by switching this switch right here. So the first 2 positions will allow me to set either one of this frequency, 432, 528, and the third position is for the pulse generator, and the last position here is for the line in. Right now this simulates line in. This is another frequency generator that I connected to the 5 volt source on the board here, and I'm using it as an additional input. So I have 4 inputs and I can switch in between them. Okay, we're gonna play with input number 3, which is this pulse generator, and I'll show you the frequency and how this circuit works here. Also, I have a couple of filters here. These are passive filters. They're for frequency, one for this. Anyone who would want to go over 1000 hertz, this will block it and won't allow it to go into the circuit and into the MOSFET here. So another filter is for line in. So if anybody's tried to drive in with a signal that's over 1000 hertz, this will block it. So there is 2 passive filters here, and that's about it. Very last thing is this board here with bunch of relays. Last 2 relays is just power relays to turn off and on everything with a simple switch right here, and this is a 5-position switch which allows me to set the voltage on this transformer to come out from this transformer. Basically, if I select the last position all the way to the left, I will turn everything off. The first position, when I click it, I'll get 60 volts. Only the top windings activated and fed through the diode bridge and into the capacitor bank. And right now my meter is connected to the capacitor bank. I am reading 85 volts on the capacitor bank. So they're a little bit charged. They can charge to 450 volts, but in this circuit I'm only charging them to about 400 volts ish. So every time each position is about 20% increments in voltage. So I have this circuit here with this switch that controls it, and it switches these relays in a way that these relays are switching 3 windings in between them to give different power voltages into the capacitor bank. We're gonna play with the first setting, and later on I'll show you the latest ones at how coil behaves when high voltage is applied to it. Fairly high, 400 volts. I consider it pretty high for PEMF device. So hang tight, let's get it activated.